in this chapter, basically we will discuss how many topics basically we have to cover. So the first topic in this chapter was about types of numbers, which we discussed. What are the different
Ma'am,
types of numbers? Yes, Harsha.
ma'am, in triangles, are there any exercises which are omitted?
Wait, I have to open the book. Can't recall at this moment. So exercise 6.1 is there, 6.2 is there, right? And 6.3 is also there. How many exercises are there in NCERT? 6.3, right?
Ma'am, 6.5 and 6.6 is optional.
Yeah, optional one we are not doing. Yeah, so the last two I think were omitted. Yeah. Only up to 6.3 we did, right?
Yes, ma'am.
Okay. Okay, then I'll do one thing, and after doing this revision, I'll update you the syllabus. We can discuss the syllabus again chapter wise. What exactly you have to do, what you have to omit. Right? Is that
Okay,
okay?
ma'am.
Okay.
Thank you.
Okay, types of numbers we discussed in this chapter very quickly. First was natural numbers. Okay, what are natural numbers? Now you have to unmute your mic, both of you.
Ma'am, the counting number starting from 1.
Exactly. So it is represented by n, and this set is 1, 2, 3, and so on. Like this complete set of number is called natural numbers. Then second kind of number is whole numbers. Represented by W, where we also include 0, 0, 1, 2, 3, and so on. This whole number. Then third, integers. So if we also include negative numbers, we get a set which is called integers. So this set is actually -2, -1, then you have 0, 1, 2, 3, and so on. This complete set is called integers, right? Then fourth
Yes,
type of number is rational number. Rational numbers is like any number which is of the form P by Q, where Q is not equal to 0, right? And P and Q are integers. So integers means they can be positive, they can be negative. Got it? And the denominator, obviously, it cannot be 0. So this P by Q type of number are called irrational numbers. Then fifth, we have irrational. So number which are not rational, the remaining numbers are irrational. So we can say not of the form, not of the form P by Q, where Q is not equal to 0. Understood. So basically, what are irrational number? Let me explain a little bit. So far, you know that only about under root 2, under root 3, under root 5, right? So basically, when you have fractional power of numbers, right? When the power is not a whole number, but you have fractional power, those numbers are called irrational number. Now this 2 is root 2 is basically 2 to the power half. Clear? This is 3 to the power half. Now, does every number is irrational in this way? For example, I take under root 4. So this 4 can be written as 4 to the power half, right? Now, by this definition, that if the power is fraction, it should be irrational. No, but because this 4, I can write 2 square and then power half. So it will become 2 to the power 1, which I get 2. So the number which are perfect square, they will not be irrational. Understood?
yes, ma'am.
Yeah. Now, what about this cube root of 2? This is again irrational number because I can write it as 2 power, 1 upon 3. Clear? This is again irrational number. Or I can take 2 to the power 2 by 3 or 2 to the power 1 by 4. All these are irrational numbers. But in your syllabus, you majorly come across only this under root 2, under root 3, under root 5 kind of numbers. Basically square roots. Clear?
Yes, ma'am.
Okay. So all of them are irrational. Yes. Now, second topic is a term which is very important in this chapter, which is coprimes. What are coprimes? We have discussed it. Let like Hcf of two numbers, let's say a and b, is 1, right? Then we can say a and b are coprimes. So this term is actually used in the proofs later on. This is an important term. HCF1 means there is no common factor. What is HCF? It is highest common factor. Okay. So there is no common factor apart from 1. So for example, 2 and 3 combination I can take. There is no common factor between them apart from 1, or I can take 5 and 7. So all of these are coprimes, right? Third, then we studied was the fundamental theorem of arithmetic. Now the statement of the theorem is not important. You don't have to memorize the theorem, just try to understand very quickly. So this theorem basically tells you about composite numbers. Now what are composite number, Hamna? Okay, now before theorem, first of all, differentiate between prime and composite. Prime numbers, you know how many factors are there between them? Okay, sorry. If a number is prime, how many factors does it have? Harsha.
Ma'am, one in itself.
So basically 2 factors, right?
Yes, ma'am.
So that is the definition of prime number. It has 2 factors, and composite number more than 2 factors. So that is the definition. So the theorem, fundamental theorem of arithmetic says that any composite number, that means numbers of this type, let's say 4 or 24 or something like that, which will have more than 2 factors. So first of all, they can be written as product of primes. So you can break down any composite number into product of prime numbers. Clear? Okay. Now, secondly, it says that this combination is unique. I mean, this prime factorization is unique. For example, I have number 6, right? I'm doing prime factorization. So 2 into 3, 3 into 1. So 6 is always 2 into 3, like 2 to the power 1 into 3 to the power 1. I cannot add 1 2 from my wish, or I can remove 1 3 from my wish. No, 6 is always 2 into 3, right? Okay. That is, and it is irrespective of order. Irrespective of order means if 6 can be written as 3 into 2 also, there is no issue. 2 into 3 or 3 into 2 doesn't matter. So we have broken down a composite number into product of primes. This prime factorization is unique. I mean, you will always get 3 into 2. And you can write it into 2 or 2 into 3, doesn't matter. So that is fundamental theorem of arithmetic. Let us see what kind of questions can arise from this theorem. Clear? First is a direct question. They can ask you, first type, find the prime factors of. Let's take a small number, first of all, 120, right? So how you do it? You write 120, then you can start from 2 or 5. 5 into 2 is 10, then 24. Now 3 into 8 is 24, right? Yeah. Then 2 into 4, 2 into 2, 2 into 1. So the 120 can be written as 5 into 3 into 2 into 2 into 2. So that is the prime factorization of 120. Now can you tell me the prime factorization of 3, 8, 2, 5 quickly?
Done, ma'am.
Okay. Yeah, what is the answer?
5 squared into 3 squared into 17.
Okay. Hamna, please unmute yourself, Hamna. Anyway, so some homework I'm giving you. You can find the prime factorization of 5005 and 7429. That's your practice questions. Now, second type of question can be put up like this, which will be based on uniqueness, right? Of fundamental theorem of arithmetic, I'm writing in short. So we have done this part, right? Now let's say on this part, what kind of question can be there? Write down question, example. Prove that there is no natural number n for which 4 to the power n ends with digit 0. So let's see how we use the uniqueness part here. Now, first of all, if any number which is ending with 0, so we know that it should be divisible by 5, right? So you can
Yes,
write
ma'am.
this. You can write this line that for a number to end with 0, it should be divisible by 5. Right? Or we can say that 5 is one of the factor. Okay. Now what about this? 4 to the power 9. So if I do prime factorization of 4, so I get 2 into 2 to the power 9, right? So we can say that just try to understand like how we have to arrive it. So the only primes in factorization of 4 to the power n is 2, right? Okay. There can be no other prime. Why we can say this? From uniqueness of fundamental theorem of arithmetic. So this is like here I'm using that part. So 4 is always 2 into 2, right? There is no chance that somewhere I get 4 is equal to 2 into 5 or something. So there's no chance of any other prime. It will always be 2 into 2. That is the uniqueness part of the theorem. Okay. So that means there's no chance that 5 is going to appear somehow. So we can say that 5 does not occur, sorry, not appears. 5 does not occur in the prime factorization of 4 to the power n for any n. You take any value of n, you will never get 5 as a factor. So therefore, 4 to the power n does not end with 0 for any natural number n. So another question is your homework on this. So check whether 6 to the power n, it's an NCERT question, can end with digit 0 for any natural number n. The same way you have to do it. Right, like 6 to the power n will be written as 2 into 3 to the power n. So there's no chance there is 5, right? You have to repeat all the lines and that's it. Now, fourth topic of this chapter is there can be questions on HCF and LCM. How to find HCF and LCM by prime factorization method. Okay. First of all, what is HCF? Like, how do we find HCF? So we take product of smallest power of each common factor. Now, how do we find LCM? Product of greatest power of each prime factor. Now underline few things. So it is the power product of smallest power, right? Of each common factor. So you have to take only the common factors. Now LCM is greatest power prime number. Whether it is common or it is not common, you have to include each prime number. So this each is important. Here only common you have to take. Now an example question can be this. Find the HCF and LCM of let's take 90 and 144 by prime factorization method. So how do we do it? You do prime factorization. So we do 90, right? Start from 245, then 5 into 9, 3 into 3, 3 into 1. So 90 can be written as 2 to the power 1 into 5 to the power 1 into 3 to the power 2, right? The next number is 144. 144, 2 into 7 2 into 3 and 36, 2 into 1 and 8, 2 into 9, 3 into 3, 3 into 1. So 144 can be written as 2 to the power 4 multiplied by 3 to the power 2. Clear? Okay. So HCF is equal to power of smallest power of each common factor. So what are the common factor? You can see there's a 2 in both of them, right? And what is the smallest power of 2 here? That is 1. So 2 into 1 you will take. 5 is not common. 3 and power is same, so you take 3 square. So that is 2 into 9 and that is 18. So HCF is 18. Now LCM, you have to take all the factors and the greatest power. So 2 power 4 into 5 you will include and then 3 to the power 2. Why you will include 5? Because uh, basically this can also be written as 5 to the power 0, right? So the highest power is actually 5 to the power 1 in any case. That becomes 2 into 2 is 4, 4 into 16 into 5 into 9, which you can multiply. So you'll get 720 here. So that is your LCM. Fine, Harsha?
Yes, ma'am. Ma'am, so in LCM, we'll have to multiply all the factors, right?
Yes, all the factors.
Okay.
See, as I told you that you cannot see a 5 here, but you can write 5 to the power 0. There's no problem, right? So basically 5 you cannot leave. You will use the highest power of 5 also.
Okay.
Okay, one practice question or homework we can say, write down, find HCF and LCM of 40, 36 and 126. So 3 numbers together you have to take this time. 40, 36, 126. Okay, fifth topic here in this chapter is basically this formula. Based upon this, questions can be asked. The formula is that HCF of two numbers A and B and multiply by LCM of any two numbers A and B is equal to the product of the number, right?
Yes, ma'am.
Okay, write down a question. Let's see. Find the LCM and HCF of find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to product of integers. So this type of question can be put up from here. So as an example question, I can take 404 and 96. Let's take, right? Okay. So first you multiply. Okay, find the HCF and LCM first of all. So you find the LCM and HCF first of all. 404 into prime factorization. So 2 into 202. 101. How can I divide it? 101. Now, is it a prime number? 101. It's a prime number, right? 101 is not divisible by any number. So 101 by 1. So 404 is actually 2 to the power 2 into 101. Clear? Now you do 96. 2 into 4 and 2 into 8. So 2 into 2, 4, 2 into 1 and 2, 2 into 6, 2 into 3, 3 into 1. So 96 is 2 to the power 1, 2, 3, 4, 5 and into 3 to the power 1, right?
Yes.
Okay. Now HCF is only common. So 2 to the power 2, smallest power. That's it, which is 4. LCM is you take 2 and power 5, greatest power, into, then you have to take 101 and then you have to take 3 to the power 1, right? So it will be a large number. 2 to the power 5 is 32 into 101 into 3. Now please multiply this. So 101 by 32. So I'm getting this 9696. Please check. Just 1 minute. Yeah, Harsha, are you also getting the same?
Yes, ma'am.
Okay. And now for the verification part, which you have to do here, you can use this formula. Clear? So you also multiply the numbers together. So what were the numbers? They are 404 multiplied by 96. So you have to check it. Okay. So you will check this thing and then you will multiply the x into m, and if they both should be actually same. So you have to prove it. So I'm leaving that part. Okay. Let's see next type of question. Write down. You can say second type on the same formula that given that HCF of two numbers 306 and 657 is equal to 9, right? Find LCM. And that's it. So the two numbers are also given. HCF is also given. You can find LCM. You can write HCF into LCM is actually A into B. Clear? Now you have to find LCM. So LCM will be A into B divided by HCF. So I hope you can do it. Or third type of question can be like this. The LCM and HCF of two numbers are 180 and 5 and 6 respectively. If one of the number is 30, find the other number. Right? So again, same formula you have to apply, that Hcf into Lcm is equal to A into B. So here Hcf is how much? It is 6, and LCM is given in the question, which is 180, and let you know one number is 30. Okay, you have to find the other number. So you put everything here and you can find B, right, Harsh?
Yes.
Okay. Now one more type can be this. Write down first. Find the smallest number which is divisible by both 306 and 657, right? And another type can be this. We will solve both. That find the largest positive integer that will divide one two five one 9377 and 15628, leaving remainder 1, 2, 3 respectively. See, these questions were previously asked in CBSE exams. I have taken that. Yeah, have you written? Now see, first type. Now find the smallest number which is divisible by both, right? Smallest number which is divisible. So that means you have to find the LCM. What is the full form of LCM? It is least common multiple, right? Least means it is actually the smallest multiple which is there. You can have other multiples also, but the smallest multiple is LCM and it is a common multiple. So find the smallest number which is divisible by both. That means you have to find their smallest common multiple. Is that okay? So in this case, the answer is actually LCM of these two numbers, which you can use, or you can find by prime factorization method. So I'm leaving for you. The answer is basically LCM in this case. Now come to second type. Find the largest positive integer. You have to find largest that will divide these three numbers. Okay, now first of all, this is actually an additional part in the question. Just don't worry about it. When you have to find the largest positive integer that will divide. Okay, that will divide means that is a factor of all the three numbers. Okay. Answer is actually HCF. What is HCF? It is highest common factor. Try to understand this thing. So HCF is actually a factor. Common factor means if you are taking LCM of HCF of three numbers A, B, C, right? So it is a common factor. That means it's a number which will also divide A, which will also divide B, which will also divide C. And it is the highest common factor. Understood? There can be other also, but the highest one which will simultaneously divide which can divide all the three numbers is the HCF. Okay. So when you have to find the largest positive number integer, that means the answer is actually HCF. Is that clear? Now before that, there is an additional line that leaving remainder 1, 2, 3 respectively. So HCF means it exactly divide. There is no remainder in this case. So first you have to find the exact numbers. That means 1, 2, 5, 1 and the remainder is 1. So you subtract the remainder, you get 1, 2, 5, 0, right? 9377 is leaving a remainder 2. So basically the number which is exactly divisible is this, right? Now this 15628 is leaving a remainder 3. So 15625 is exactly divisible by this HCF. So the answer is basically you have to find HCF of these three numbers 1250, 9375 and 15625. So again, I'm leaving this for you. Understood?
Yes, ma'am.
Yeah, so basically this kind of questions can come because simple prime factorization that you have already done in previous classes also. So slight change in the definition or language of the question can be there. Now come to irrational numbers. So this much was about rational numbers we were dealing. Sixth, there's a theorem. First of all, recall the theorem, which we will be using now. Let P be a prime number. Okay, and A be any positive integer. Underline these things. It's a prime number. It's any positive integer. Okay. Now, what is the theorem is that if P divides A square, then P also divides A. Right? That is the theorem. Right. So seventh topic from this chapter can be this, proving irrationality.
Ma'am, your voice is breaking.
Is it fine now? Sorry, there is actually some network issue from my side today.
Yes, ma'am, it's better now.
Okay. So seventh topic is proving irrationality of numbers. Let's revise one proof which we have done before. Prove that under root 2 is an irrational number. Okay, so proof. So we use the method of contradiction here. That means we start by assuming that under root 2 is rational, and in the end there will be a contradiction, and then we will say that no, it is irrational. So let under root 2 is rational. Okay. Then there exist coprimes such that under root 2 coprimes A and B you can take such that under root 2 is A upon B. See, any rational number, now try to understand, any rational number is of the form P by Q. Clear? When we are taking it rational, that means it is of the form P by Q. So it can be a number like this, for example, 6 by 6 by 4. It is of the form p by q. But we don't want this kind of number because we can see that 2 is a common multiple here, right? Numerator can also be divided by 2. Denominator can also be divided by 2. So we do not want this kind of number. We want numbers like this, 3 by 2 or 5 by 7. So there is no common factor between them or common multiple between them apart from 1. Is that okay? And such numbers are actually called co-primes, right? So this term is important. So that means there exist co-primes a and b such that under root 2 is equal to a upon b, right? Okay. Now you just square both sides. So under root 2 whole square is equal to a upon b whole square. So 2 is equal to a square upon b square, or 2b square is equal to a square. So from here, what can I say? Now see, a square is 2 into something, right? So basically, I have broken down my a square into two factors. One factor is 2, another factor is b square, right? That means 2 is one of the factor of a square. So I can write that 2 divides a square, right, Harsha?
Yes.
Okay. And by the theorem, I can say that 2 divides a. Theorem. So this result is result number 1. Now, because I'm saying that 2 divides a, that means 2 is one of the factor of a. So 2 into something will be equal to a. Is that okay? C is any integer, right?
Yes, ma'am.
Yeah, for some integer C. Right. Now again you do square. So you get 4c square is equal to a square. Clear? So 4c square is equal to, now in place of this a square, from here I can write 2b square. So 2c square is equal to b square. Again I can see that b square is 2 into something. That means again 2 is a factor of b square. So again I can write that 2 divides b square, and then I can say that 2 divides b, again by theorem. This is my result number 2. Now if I look at my result number 1 and 2, 2 is also dividing a, 2 is also dividing b. That means 2 is a common multiple between them, or a common factor, so not common multiple, common factor between them, right? 2 is a factor of a also, 2 is a factor of b also, right?
Yes, ma'am.
Okay. Now this is a contradiction because we have assumed a and b to be co-primes. That means there is no common factor between them. But here we are getting 2 as a common factor. So we write including line that from 1 and 2, 1 and 2, we can see that 2 is a common factor of a and b. So this contradicts the fact that a and b are co-primes, right? Therefore, our assumption is wrong. Hence, our assumption is wrong. So what was the assumption? This was the assumption that we have assumed it to be rational. And therefore, under root 2 is irrational. So as in homework, you have to prove that under root 3 is irrational, then under root 5 is irrational, right? Same lines you have to write. And one of them can be asked in the exam.
Okay.
So exactly same way, in place of 2, you will get 3 there, and in 5, you get 5 there. Now, second type of numbers can be right 3 root 2. Prove that to be irrational. Prove that 3 root 2 is irrational, right? So again, we use the method of contradiction. So let 3 under root 2 is rational, right? So there exist co-primes A and B such that 3 under root 2 is equal to A by B, right? So you keep the under root 2 part one side and take everything other side. Now, if the question comes in 2 mark or 3 mark, right? So you don't have to prove separately that under root 2 is irrational. But if it is a 4 mark question, then you will prove the LHS to be irrational and RHS to be rational, and then you will say there's a contradiction. Is that okay?
Okay.
Okay. Now, LHS, we already know it is irrational. LHS is irrational here. Now, what about RHS? So RHS is A upon 3B. What does it mean? Or you can, show, don't write it here. LHS, you already know. Make a line and then you can show this thing here, right? So A upon 3B. So A is what? A is basically an integer, and divided by 3 is an integer, multiply B is an integer, right? So this will give you integer divided by, if you multiply one integer by another integer, if it is not 0, so you again get an integer. And integer by integer means P by Q form, right? Which is rational. Got it?
Yes.
Okay. So this contradicts the fact we can say that RHS is rational. This contradicts the fact that under root 2 is irrational. So that means you already know that under root 2 is irrational. You don't have to prove it. Hence, our assumption is wrong. Or not correct. And therefore, 3 under root 2 is irrational. Now, next type of question, which you can say third type, you can have numbers like this, 5 minus under root 3. So one number you can see rational, other is irrational. This combined, you have to show it as irrational, right? Prove that 5 minus under root 3 or 5 plus under root 3 is irrational. So I'm not writing all the lines. You will write the line here that let us assume it to be rational, then there exist co-primes and all and all. So 5 minus under root 3 is A upon B, right? So you keep the root one side. So 5 minus A upon B is equal to under root 3. Clear? So you look at your LHS now. It is 5 minus A upon B. So you can take LCM. So 5B minus A divided by B. Clear? So 5B means 5 multiplied by some integer, which is again an integer. So you get integer minus integer divided by integer. So again, you get integer by integer form, right? Which is rational, P by Q. So again, you can conclude that your LHS is rational. This contradicts the fact that under root
3 is irrational, hence our assumption is wrong, and hence 5 minus root 3 is irrational. So I hope you can write it. Same lines you have to write, right? Okay, one more type of numbers can be there. For example, prove that under root 2 plus under root 5 is irrational. Like both the numbers are having under root. Clear? Now how will you do it? So you will repeat all the lines. So ultimately you get under root 2 plus under root 5 is equal to a upon b. Yes, Harsha, can you write all those things on your own?
Yes, ma'am.
Fine. So you keep one number one side, take the other side. So I'm keeping under root 5 here and a upon b minus of under root 2. Now square both sides. So I get 5 is equal to, this is a minus b whole square. So a square plus b square minus 2ab. So a upon b whole square and minus 2ab and plus b square, right? So 5 is equal to a square upon b square minus 2 root 2a upon b and plus 2. So here you can spot your under root 2. So keep this term one side, other terms other side. So I'm bringing it on the left. So 2 under root 2a upon b is equal to a square plus b square plus 2 and then minus of 5, right? So 2 under root 2a upon b is equal to a square upon b square minus of 3. So you take LCM. LCM is b square. So a square minus 3b square, right? So 2 under root 2 into a is 1b will get cancelled out. So a square minus 3b square divided by b. Clear? So
Yes.
under root 2 will be a square minus 3b square divided by 2a. Clear? So now you have got irrational number on one side. Now
Ma'am,
look at
2AB, right?
Oh, sorry. Yes. Now look at your RHS here. So a square means integer, right? Integer square minus 3 into some integer square divided by 2 into, some integer into integer, isn't it? Integer square will again give you an integer, minus 3 into integer square is again an integer divided by 2, or again you get an integer, isn't it?
Yes, ma'am.
Okay. So integer minus integer is again an integer. So this is of the form of P by Q, which is rational, right? So please repeat all the lines here that RHS is rational and this contradicts the fact and all of everything.
Ma'am, so before this, we should also prove root 2 is irrational, right?
No. As I said, if it is a 4-mark question, then only you have to prove that under root 2 is irrational. Otherwise, you can directly use that fact that under root 2 is irrational. In case of
Okay.
2-mark or 3-mark question, you can directly use the fact that under root 2 or under root 3 or under root 5, they are irrational. Don't prove them.
Okay, ma'am.
Okay, then one topic is remaining. I think I'll take it up in the next class from this chapter, which is about the nature of decimal expansion of rational numbers. There are questions in NCERT also based upon that topic.
Okay, ma'am.
We will be discussing it in the next class.
Thank you, ma'am.
Okay, Harsha. Okay, bye.